Before we start the panel discussion, there is one announcement for tomorrow. So tomorrow morning, we are going to confer upon the Lifetime Achievement Awards to the stalwarts of the industry. So please ensure that you come on time and we start those proceedings on time. Now we begin with this panel discussion. The title which we have chosen is the Success Mantra. The Success Mantra is nothing but how successfully we deliver the structural steel projects. So when we talk about structural steel projects, there are various asset classes where we use the structural steel. Let it be a commercial building, or let it be a data center, let it be industrial, let it be logistics, residential as well, let it be hospitals or hotels, or you just name it and it is there. But even today, it is quite surprising to know that there are many misconceptions about structural steel. When I say that structural steel is a prime construction material, people still have a kind of dilemma in their mind, or they have some kind of misconception, some kind of fear. Now, it is our job today, first of all, with these stalwarts who are sitting over here, and in terms of steel, each one of them, they have tons of experience in delivering the structural steel projects. So this is what the beauty of this panel. Okay, and we have chosen this panel very, very carefully so that we have a very thoughtful panel discussion. Now, what we are going to do is basically we are towards the end of this panel discussion, we are going to have a little bit of framework, and that framework will have certain attributes. Those attributes are essential. We will conclude towards the end of the discussion. We will deliberate. We will have brainstorming session. You will see that a lot of many things happening during this panel discussion. And towards the end, we will try to build a framework with certain, let us say, 5 attributes towards the end, that if these 5 attributes are there, and if you study these 5 attributes carefully, there are minimal chances that your project will face any kind of a problem and your project will be successful. So before we enter into the active panel discussion, let us look at what are the different phases of the, not only structural steel project, for that matter, any project, but structural steel, when we talk, there is one more phase which comes in the manufacturing. So manufacturing, design, costing, construction part of it, fabrication part of it, then you complete the project, you hand it over to the end user, and then the project goes into the maintenance. So this is what normally we call, these are the different phases of any life cycle of the project. So these phases normally generate many kind of attributes or many variables. I would correct myself, variable is the right word. So these variables at in different phase of any project, these stalwarts, they study these variables in different fashion. Sometimes consciously, sometimes subconsciously. So what are those attributes? What are we talking about? So when we talk about, let us say, structural steel, the kind of products which are available in the market, or whatever our steel manufacturers, they are manufacturing their product range. Then ease of design. How much space I am going to get more if my project is designed with the structural steel, when we talk about the efficiency part of it. Then there is speed, there is scale, there is quality. Then we talk about the environment now. I mean, sustainability is a big, big buzzword right now, right? Similarly, technology part of it. And eventually, we also consider that whosoever is the occupier of that space, he should be very happy. And that is what the simple yardstick of the successful project delivery. If the end user is happy, we say that, okay, the project has come out really very well. So now let us begin this panel discussion with our design stalwarts, those who are sitting over here. I am very fortunate to have architect Atul Shah sitting on my right, Surya Prakash sitting on my left, and I have Hiten Mahimtura over here. Hiten and Surya Prakash, they are the leading structural engineers. KSP comes from Larsen & Toubro EDRC, and Hiten is running his own practice for the last 30-35 years in city of Mumbai. And we have an eminent architect sitting over here, Mr. Atul Shah. So first question I'm going to ask 3 of them, that from steel manufacturing industry as a designer or as eminent forces in the industry, what you expect from the steel manufacturers. We'll start with Atul Bhai first.
Thank you so much, Sunil, for inviting me. One of the major things which we start looking at high-rise buildings particularly is that how can we have the structure which is efficiently done, and for that what attributes we would like to have in terms of steel would be that it should have efficiency when there is fire, which is a major code requirement which we need to follow. And most of the time you use something else as paints or vermiculite concrete to ensure this is done. Ideally, we should have steel, which I don't need to use any of these. So that's one thing which we need to start looking at. What I suggest is we do one at a time.
As far as sections are concerned, obviously, for a designer, we would like to have maximum number of sections. Maybe for columns, when I think Tata Steel and the other manufacturers today mentioned they've got larger box sections, hollow box sections coming up, square hollow. Do they have different thicknesses? Because today, if you're going to use hollow column sections for columns, suppose, we need to maintain the CG. Your I sections also, we maintain the CG. To have the center of gravity, I would like the same section with different thicknesses, which is available in US or in UK. So we don't have that type of flexibility in design. Sometimes even the sections which are available, it's not on their workshop. They can't give it. Or they require a certain number of tonnage. Now, we may be doing small works, we may not doing airport all the time. So you can't give the tonnage. So how do you get this? So then we are constrained with using only certain amount of sections. So that is one major thing from point of view of manufacturers: stock, volume of stock, and availability of flexibility of maximum number of sections. I believe it's a chicken and egg game, but you all guys have to put in some sort of input and get that, because that is the only way to push the, to have a proper steel, because then we are using inefficient sections. We are using more kg and quantity because of non-availability. So that's my take on the...
Very good evening to all. I think Atul covered the fire and he covered the sections. I have not left with anything, but I'll take a sustainability part of it. Sustainability is the buzz of the time now. And India committed to have a net zero by 2070. And at L&T also we committed by 2040. So this being the case, steel production itself creates a lot of CO2 emissions, which means we're increasing the carbon footprint a lot. So what are the options we have? How do you make it a sustainable material? What are the ideas of green steel? We have both Tata Steel and Jindal. If you can share your thoughts about it. We also, travel towards the sustainability and a larger perspective and ensure that we are near to we can give a better world for the future, for our next generations. Share your thoughts, please.
So I'll add one more thing to what Hiten mentioned, is that you can always have built-up sections, but what is important is to ensure that you have sections which are readily available of same MI, of different thicknesses or different sizes, and that would make things much more efficient.
So primarily, rather than throwing any other question, I think whatever these three design stalwarts, they are asking three simple questions out of their explanation. Number one, the availability of the product, off-the-shelf availability of whatever I want to design. The second one is efficiency, that can I build efficiency using your product? And third one is asking about the sustainability. So now let us ask our manufacturing giants about it, that how they look at these three questions and how they would like to address it. Could you please start, Mr. Panda?
Good evening. Thank you for the opportunity. So I'll start with first what Hiten said about the availability of sections across sectional rates. As far as we are concerned, if you see the UB, you see what we call as a narrow parallel French beam and wide parallel French beam in India, is that you have multiple sectional weights in the same dimensions. That is so, as a manufacturer, it does not make us a difference that if you give us a 10 tons order of a particular sectional weight and another 100 tons order of a different sectional weight, it all gets rolled at one time. It is only a problem if there is a particular size which is only for, say, 50 tons, and we would have a minimum campaign size of, say, 500 tons or 400 tons to roll that. So those sections would be very far and few. And I think the only way that we can work out on this is that you and we interact much, and you tell us in advance that this is what you are planning, and we'll also be able to tell you that this is there in a regular production or this is not there in a regular production. The second thing that sir raised about the fire resistant steel, I think today morning session only we have been speaking on that we have now developed. There was a specification in BIS for the last, I think it is from 2005 onwards, that BIS 15103 is a specification which allows for fire rating of steel, wherein intrinsically, just like you have corrosion resistant rebars, it is similar to that, wherein you intrinsically add certain elements into the steel by the time of melting the steel, and that gives you a property of fire resistance. So here in this particular case, we add chromium. We have it as a high manganese steel of about 1.5%, and then we also add vanadium to this, and together with this, we are able to achieve a fire resistance of 3 hours at 600 degrees centigrade. So this is covered as per BIS 15103. It is now certified. We were the first people to get this certification. It was handed over to us on 15th of March through a special, on the World Consumer Day. It was a special function that BIS held and gave it, because this is something which was pending for so long. So this issue of using additional coating or using intumescent planes or vermiculite is now not necessary. And as we would have presented in the morning, you would have seen that we are almost 10 times cheaper than vermiculite in in intumescent in certain conditions. And in most of the conditions we would be similar. So this is the, and again, see, there is one more concern that many structural engineers have, is that the grade of steel is not available. If a section is rolled, whether it is a sectional weight or whether it is a grade, it is all rolled at one time. There is nothing that we need to roll 450 grade of steel separately, 350 grade of steel separately, 250 grade of steel separately. It can be rolled at one campaign. The only requirement is a campaign of 400 or 500 tons, and all sectional weights, all grades, including this fire-resistant steel, can be rolled at one go. So that is the third, I think Kalyan is a prime, which we have been speaking about, is that when you take RCC and steel, the steel cost becomes almost similar to RCC if you use a higher grade steel. And they have been doing that with E450 grade steel for We have done some government projects with E450 grade steel. All the current hospital projects are with E410 grade steel. So the moment you use higher strength steel, your steel cost comes down, and ultimately you are more or less at par with RCC.
Excellent. I mean, it's wonderful to know that you have come out with a product which is able to withstand 600 degrees centigrade for 3 hours. I mean, when are we going to see that product?
We have already used this product for an internal project at OPJU. We have got a OP Jindal University at Sonipat. For that stadium, we have already started manufacturing the product. The total requirement is about 1,300 tons. So it is now in the span of erection. And as I said, if you give us our order tomorrow, we should be able to supply it out.
What is the lead time for this steel?
No steel, sir.
It's a similar type.
That any grade we can manufacture at the same
And
time.
you can manufacture in 450 grade as well, the same fire resistant steel.
The fire resistant steel, currently the certification that we have and the code that is for E350.
Okay. So, but it can be applied at later stage for 450, which will be...
We will have to apply and get into a year. But as of now, the BIS code does not allow 450.
Does not, yes.
So 350 is available. And 350, if you see the code, there is that if you go up to, say, 40 mm, if you go the thickness, then the strength falls to, say, 310. But we can assure you that 350 across all thicknesses. That is something that we can do.
And one more question about the sizing part of it. We are getting some projects with 2.5 meter square sections of the CFT. So will it be possible for you to manufacture 80 mm thickness 2.5 by 2.5 square sections?
80 mm, 2.5 mm meter plates we can give you. Or
Plate bending. That is
plates
normal.
up to 3.5.
I was saying about
square section, so we don't manufacture. Sir is the right people.
that's about them. Anyway, fine.
Yeah, so in fact, it is good that he has come from Tata Steel, primarily manufacturing all tubular steel. But before you answer his question, I want you to address these 3-4 questions which he has already answered.
Okay.
And you please, if you could start with sustainability part of it or the green concept, that is better.
Sure. First of all, thank you. Before I answer the questions of the designers and architect, I would like all of you to clap for them. A big clap for them. Why I'm saying so? Because in the last few years in India, you have seen many engineering marvel coming up across country. And it's happening with all the limitations what they said. I still wonder, recently one polo player on a horse, a large statue was unveiled in Northeast using structural, happening with the limitations you're talking about. Yes, we will have some limitations across. We all say whatever you ask, even if we give you, you will have some other limitations. So we'll work with some limitations. A good thing is lots of discussion happening around and we are all trying to understand each other. Why I'm saying so? Because in last 4 years after taking over Bhushan, we see the way we have ramped up our sizes and SKUs and the volumes, something which I used to find difficult to imagine 4 years back. I used to fight with my marketing team that you bring so small orders, I can't do my size change, I cannot do this or that. Today I challenge them, okay, I will do 5 size change, 7 size change, you bring the order. There is another learning which we are making. It would be good the way he said is that if we can discuss more, is that now we have some basket. Can we increase the basket? Some item can be such basket for which order may not come regularly, but will be small SKU. I can keep as an insurance. So that it comes, now you know instead of 5, you can have 7 or you can have 9 in terms of thickness. You rightly said, as far as campaign is concerned, thickness is not a concern. But in one size, one thickness, if you give 10 ton, it will never come. So better you use a different size. So we're discussing again with my team is that once you receive the inquiry, by the time design has already happened. Now if you ask for a size and I don't have a size, there's a big challenge. Instead, can we discuss when you are doing the design and then you better know which size to be done, because sometimes time is the cost. Because if you lose 2 months in discussions and another 5 months in getting the material, you lost lots of money. Instead, you could have added 10 kg of steel. So this is one part, but certainly we'll be working more. For example, sometime back we had a discussion, similar discussion, where the team asked for 500 by 500, 700 by 300. So those are sizes we are working on. You rightly said some thicknesses. So they are a little bit challenging, but there are demands now coming up. Our own company needs similar size. So we're working on that. Now coming to green, I'm coming from another conference in the morning. So that conference was on digital and AI, but throughout the discussion, it was only environment. Only ESG, only CO2, nothing else. So also for us, it is important. And I think you know various declarations, but various companies and the country itself. Country wants to be carbon neutral by 2070. So we in Tata Steel want to be carbon neutral by 2045. It's very ambitious. Jamshedpur unit, which used to operate at a CO2 emission of around 3.1 tons per ton of steel, is currently at around 2.2. Though we have acquired some companies who are far behind. But together we want to achieve somewhere around 2 by 2030. This is not easy. In steel industry, it's very, very difficult because we are forcibly using now scrap in the place where we could have used hot metal, just because we have that aspiration. The manufacturing unit doesn't want to use it because for them, cost and everything is going for a toss. But no, it is forced. You have to use it. Why? Because now, till now, other customers are asking, this time, all of you are also asking, though you're not direct consumer. But you are asking CO2. Possibly your client will ask you CO2. Then you will ask CO2. You will ask me. So it is becoming now must to have. It's not a fancy word. So one, as far as availability of sizes is concerned, one good thing is it's available. But now how many sizes are available, that's a second challenge. Slowly it will improve. I assume more players will come into the foray. And if more players are there, the availability will improve. More importantly, the needs need to come more. Good thing now discussions are that more and more people want it. I had a very difficult situation 2 months back when I had lots of orders pending, especially on the structural side. So we were having what kind of problem it is. We were not having orders some time back. Now we are having too many orders. So we are trying to map now, as far as manufacturer is concerned. We would like to give you advanced information what are the sizes we make regularly, because even among your community, you may not be knowing how many people are using what sizes. But we know because we combine all those sizes with us. So we can share what all sizes we have been receiving from various architects and designers. It will help all of us together. We discussed, Amit, so let us do that. Thank you.
Thank you so much. Now, yeah, 1 second. You want to say something? Go ahead, KSP. No
The green seal part of it, if you can brief about it, what is the process? When are we going to get the green seal out?
Ideally, I was not, frankly, I was not prepared for, but I tried to study. It says, green steel is steel where you don't use fossil fuel. And in general, the electric arc furnace route can be green steel because it will not use fossil fuel. It can use green electricity. So, and in Tata Steel, we are having very ambitious projects on this route. We have just started in Ludhiana. We'll be having many more such units coming up. So we have both the plants being carbon neutral, which means whatever carbon you generate, you absorb. Whereas green steel, you don't generate carbon. So that's a key difference between two.
So does that answer your question,
I think
KSP?
still it takes long time as per the discussion. But probably when you say net zero production, that may be possible soon by 2030 or so. I don't know if you can. So it's a long way to go. Okay.
Okay. So now we move to the construction expert, cost expert, contracts expert. We have Kalyan with us, who has specially come for this panel discussion from Hyderabad. And he is going to talk about, by not comparing it with RCC, because probably this session itself, the dilemma or the confusion, misconceptions, all the time, our community itself is so busy in comparing structural steel with concrete that itself is not right. Because both are prime construction materials, both have their certain strong points and few weak points. So from that point of view, I'm now going to ask Kalyan that how he looks at structural steel as a material when we talk about the cost part of it, when we talk about the scale part of it, when we talk about the speed part of it. So Kalyan, you can share your thoughts on that.
Good evening, everyone. Thanks for inviting, and it's a wonderful thing in terms of understanding various perspectives from various panelists. The question for me, if I understand rightly, is my perception or our perception in terms of steel construction and its ability or impact in terms of speed or any other aspects. Okay, for me, steel construction is something what I perceive to be the, it's an opportunity at the time we are in today. It's about time is money, and today the pace at which we are developing and the pace at which we have the demanding from the clients, it is how we deliver the project in time, in quality, and in a predictive way in terms of anticipating timelines also, and anticipating in terms of what delivery can be given at what time. So steel, for me, it is about speed in terms of the primary thing. Second, I see it is a modular approach in terms of construction, which unlike any other construction technology, we have several elements, several sequencing of activities are required when compared to that of steel. It can be more modular, where you can have the complete fabrication is done at factory in a controlled environment, and you can bring that back into site and erect it. So you have much more clear delivery which can be bought in. So these are two things which I see is a major thing. Other than that, what I foresee is that it's more sensible. It is sensible in sense of sustainability. For the reason I slightly differ in terms of green steel and all, because we are seeing only as a production of green, but I see, or probably we should see it in a holistic way, where it should see in terms of scope 1, scope 2, and scope 3 also. Because if we get a steel which is green, completely produced in a green environment, but all other activities you do non-green, it is still non-green. So it is about bringing in that sustainability throughout the supply chain has to be brought in, and collectively we have to work to see how best we can get utilize of our infrastructure what we have, and how do we actually put that in sequence where the entire supply chain comes out to be sustainable. So for me, a sustainability angle, that's something what I feel is much more, and definitely consultants and in terms of fabricators, consultants, suppliers, everybody should come together to make it happen. So this is how I perceive steel to be.
But how you, I mean, if you have to talk about structural steel projects which you are doing in Hyderabad or any part of the country right now, and if you have to talk about the speed, quality, safety, as well as the scale on which you are working at when you are doing those projects, what is your opinion that each and every attribute, I mean, would you like to speak something about these attributes? Speed, cost, quality, and scale.
Cost is a trade-off. So certainly steel doesn't come cheaper in terms of its approach, but it comes wiser when you actually choose in a right sequence, in a right positioning, if it is done. So basically the time at which, time or a pace at which a construction can be done, it certainly gives an opportunity cost on the project, which can then be traded off, then it certainly becomes economical. So you need to see the function and the requirement on the project, and that's when the positioning comes out. In my opinion, if you say quality, safety, these are something which are, for me, safety is first, quality, it is not second, for sure, but then, yes, safety becomes first, and for any project, irrespective of steel or anything, that remains same. And for every technology what you go with, there are associated safety measures which need to be taken. 100% the opportunities are enormous in terms of implementing safety features, particularly in steel. So because one simple example what I would say is like in today's morning presentation, there was a good presentation which was shown. A steel structure to a RCC structure, you can think about having how many activities on an RCC structure to an activity which is on a steel structure. So the number of elements and number of levels at which the activity happens in RCC, there's amount of an effort which is involved to ensure that safety and quality is maintained at those many levels. Now, this is one-time correct approach which can be bought in steel, because you do and you keep moving. And the moment you do a floor perfect, then actually you can do rest of the activities in sequence and doesn't have to wait for the subsequent flows to be done, unlike in RCC.
So it's very easy to achieve the desired mechanization in steel as compared to other materials,
Absolutely,
right?
absolutely. And that is one of the key, you can say, KPIs on steel, that mechanization is possible. Unlike RCC, you can still go mechanization in RCC, but amount of opportunity what you have in is much better in this.
Yeah, you're perfect. From a contractor's perspective of L&T, we do both concrete and steel. Of course, our steel part is almost 30% and concrete is 70% steel. But at the same time, the team feels so comfortable to handle the steel with respect to safety, as rightly said by Kalyan, and also the quality perspective as well. We were masters at once upon a time in the concrete as well, but when the steel comes in with the control of quality and the checklist, what do we go for ITP, it's quite easy and decisive to ensure that the quality is correct. We got separate test enlisted for the quality of the structural steel, and we go through the process rigorously to get it right at the first time. So definitely steel is very good with respect to safety as well as quality, and that's recommendable with respect to contractor's perspective as well.
So I feel probably apart from your infrastructure project, why there is so much difference is probably because a lot of buildings are not in steel, which are residential. Now, the way things are, particularly in Mumbai, we will need to start looking at steel because the size of the structure, the height of the structure, and the speed which is required. So I believe in next couple of years, you may change this percentage.
Now, before we move to the next topic of this panel discussion, where um, Atul Bhai is going to take us to the future, I want K. Surya Prakash to take us what L&T has achieved in 45 days. He is going to narrate that complete story in front of us, that taking structural steel as a product, how did they deliver that product? Go ahead, KSP.
It should have been ideal with a presentation, but anyway, now to keep it in words, it's very crisp and I may not be able to explain so fast, but then let me see. So it's a ground plus 7th storage structure. It's for defense project. It is done in 45 days, as he was explaining. But whole concept is about prefabrication. You don't go for, on-site without planning and design. In fact, we have spent almost 6 months in doing the complete design and planning. And afterwards, we gone for fabrication. We did the fabrication after getting all the elements of steel columns as well as the floor plates. And we erected one floor, including the services, floor finishes, and the panels, which are wall panels. We just lifted up. The cycle time is almost, 1 day, you can say. So you can, basic time takes for the foundation. Of course, we excluded the foundation time in the 45 days, to be clear. But afterwards, once we started the floor erection, it takes minimum time because we are fabricating. After fabrication, we are erecting directly at the site part of it. We did see similar project, to be precise and frank with you, a broad group in China, which does similar account. They also have a different concept. Our concept is different, their concept is different. They do hotels and residentials within 57 days, 95 stories kind of building. These are the speed what they do. And we could achieve in India also without their fabrication facility and without our own fabrication, and completely modularized. Nothing goes out. So that's why the planning is very important. 3 parameters which are very accurate you should have is the planning, fabrication. You cannot have mismatch between the fabricated and the erected part of it. You could not have time to waste on that location. The fabrication checking, which has to be perfect, and on-site erection on spot. These 3 parameters gave us much, faster pace. In fact, we thought it will go up to 57 days, but then, we could make it in 45 days as well. This is in crisp or in short, it is a story, but presentation will be much more fascinating to see. Anyway, thank you.
Thank you so much, KSP. Now, again, before we move into future, there are certain fundamental things which I want to take with Atul Bhai. Atul Bhai is an architect, and we can say that the first dialogue between the client on design, it starts with the architect. So when we talk about certain parameters, like, first of all, getting the acceptance of the client when we talk about structural steel as a prime construction material, how he manages to, he has delivered quite a few structural steel projects in city of Mumbai and other places as well, let me tell you. So how the client reacts, what all he has to tell, and then how efficiency or ease of design, and then the client satisfaction of the end product, how he sees all those things so that the project is delivered successfully. And then we will go towards the future of construction. Please.
Wow, that's a full gamut. So what we have found is principally any project, you don't start with designing for steel. You're designing for a project with specific requirements. Some of the project has requirement in terms of how quickly you want to build, because there were a lot of rehab tenants which needs to be rehoused quickly, or there are a lot of shops which needs to be rehoused quickly. So one of the criteria was, how do you build quickly? So the time was one of the criterias. One thing which I should point out here, both L&T and Kalyan, they go into so much detail, and the crux of delivering project in good time is going into detail. So devil is always in detail. So Kalyan was telling me about an hour back that he counts number of pieces which needs to be put in the building. And the same just now what they were mentioning about 45 days, how they delivered. So in specific, it's not just designing for steel or concrete, it is designing in detail. If time is the criteria, it would tend to be tilted towards steel much more easily. Of course, there are other projects which we did, which was not time sensitive, but space, how that space would look. As soon as you have, say, 2 million square feet of office building, the space is very important. The concrete columns are going to be much larger than, say, steel column. Right now, we are looking at stainless steel columns. So that's something which is very interesting. 316 steel is getting available, and you don't need to encase them. You can do that very quickly. So there are a lot of new product which is available, and it is possible to do things which would be much more beneficial to end users also, apart from the developer. Does that answer your question?
It does, it does. So the sub-question was, when you look at structural steel from the viewpoint of an architect, where the efficiency of the space or aesthetics or other parameters, when conventionally in the history or in the past you were dealing with concrete structures, what kind of difference or the advantages you see going ahead with structural steel?
So I should admit, when we started, we were looking at how can you kind of replace concrete with steel. Now we are looking at steel which is external. So, I mean, people who are architects would know Mies van der Rohe designed steel which was externally shown, and it looks just fantastic. So apart from what Kalyan would think in terms of efficiency, probably what it can give is phenomenal aesthetics which is as good as permanent. So it has tremendous potential, scope to deliver what you want to do. Unlike concrete, most of the time we feel that there are a lot of limitations in steel. We have found other way around. So most of the time, Hiten would say he would need sizes of beam which would be much larger in concrete, and which is not what an architect would like to have. So steel, we found that much more easily achievable. And that's something which we found is much more easily malleable. You can design things much more sleeker and deliver things which is much faster, for sure.
So now I go back to Hiten, that whenever an architect comes to you, that I have X 100 square feet of floor plate, and please remove all your ugly columns from that floor plate, how do you address that situation, and how steel can help you if you have to give solution to an architect? Because eventually we structural engineers are the solution providers to the architects, right? So how you address that, how steel can come to your help to achieve architect's vision?
Thank you. First of all, let me address one point. Kapil, you mentioned that with all these constraints, we have been yet making good structures because of plates, not because of your sections. We are using plated sections. We are forced to use plated sections. Because of that, we can achieve it. So we need your help desperately.
No, my reference
That's
was
what
more towards
we need
airports.
manufacturers' help so that we can make things faster and
Agreed.
even faster. Instead of plating and doing on manufacturing, why don't you give us regular sections so we can do a good job? And
My
faster
reference
job.
was more towards these marbles made by rounds and RSS and SHS.
Can I make a point on this?
Yeah, please.
So just particular plated sections, what today Mr. Sapru was presenting, the
Yeah.
KL Reja project.
Yes.
There was a certain section, 457 into 191, where the maximum tonnage that sectional weight that we manufacture was 92 kg. And he wanted that it should be somewhere near 134 kgs. It is not there in any UB section guidelines. But we could see that if we could increase the flange width and the web thickness, then we were able to achieve that. So 134 kg, 161 kg, and I think another 124 kg or something. 3 sections we developed for him. The total requirement was not more than 400 tons. But that is something that we don't, and he did not want to use a built-up section in that. He wanted a roll section. So I think if we collaborate this...
Yeah, so basically a lot of planning is required in advance, as you're saying. Then you can provide the details. So it's because we are all in the misconception that you require minimum tonnage. Because if you go for some special sections, that is something which needs to be spread out to the designers. That even for smaller sections, smaller quantities, you are ready to do it. That has not gone to everyone. That we are not aware of. So these are the things where these seminars where, when you're designing, because what happens when you're designing, when a designer does all this, he has to look at client's requirements, architect's requirements. Architect's requirements are, forget beams, forget columns. Make it as simple, as clear as possible. But there are some limitations, basically. And what happens is that the facade, now the facade can be, as you were saying, Atul was saying, that we can use the facade aesthetically. We can take curvatures, we can do what we want in steel. That is the versatility of steel. So not only it's sustainable, but it's versatile for taking any shape, any form you want. So that's what we can give. Now what happens is that with 450 MPa, 460 MPa coming up, we could go for very sleek sections, thinner beams, where you can have flexibility of services and all that. And your column sections, it's a trade-off. Either you go for encased sections or you go for tubes, infill tubes, IFTs. IFTs has got a trade-off on steel, but faster from point of view of going up. So these are the things we need to take. So obviously we can go for large spans, less columns, smaller columns. So that's the thing which we can give to the end user. Not only our client, but the client's end user. That's what they want, finally. But the main challenge is that when you have a facade, everyone talks about steel with glass. That's what the concept is. It's easy. Everyone knows the details. What happens if someone wants to do something different, facade-wise? Like you want to have a classical architecture. Can you do that with? So those are the challenges we are facing today. For that also, we can pre-plan, but it slows down the process because you want arches, you want columns, you want all that. Can you have that with steel? So that is what we need to see how. So you can do a precast elements. You can go for all those issues like
precast one, but then on the arch part of it in structural steel, we are now doing the Mahimtura airport, wherein the span is 70 meters. So I know Francis is there. They were the designers earlier for the scheme. But it was so complicated that you need to have an arch completely of 70-meter span, which is, of course, following the profile. But the sections are requiring, 670 by 50 thickness, which is, anyway, you go to plate bending. You can't go anything. So those are the requirements which, I don't know, how will you make it customized? Then it will be benefiting the manufacturer as well as us as a contractor and designer as well. So
yeah, but in infra, you can afford the cost.
Yes.
In a commercial project, you can't afford all this.
That's it.
So, you need to come up with some other solution,
That's right.
lighter solutions, precast solutions, GRC solutions, how you can
Exactly.
fix.
I was just about to say that. Coming to the architecture thing, gaudy kind of a thing probably cannot be done. But I'm saying we are actually doing with the GRC in one of our projects, which is about 13 floors and 6 parking. So all the office floors, balconies are cladded with GRC as a design element. So the necessary support system to the steel has been made as part of the design element, and subsequently that will be embedded. And one other project also as an element, part of it has been now put with the GRC. So GRC implementation into steel has become much easy because that needs a frame which embedding onto the steel comes out much faster and easier when compared to any other thing. So I'm saying that is possible and it can be done. Yeah, I agree with you in terms of the cost. Yes, again, it has to be cautious in terms of what we are spending, and it has to be in the cap what we are looking at to make it commercially viable. So again, I roll back. Anything what you give, there will be another requirement coming in. He said, yes, fire-rated steel 350 grade done, but I'm saying that is only on the rolled sections. So we need plates. Please help us out.
So, in fact, Hiten, when I asked this question of a clear slab without any columns, I was actually hinting you towards that probably will talk about the die-grid systems. So would you like to talk about it? And then KSP also can throw a lot of light on die-grid buildings.
Yeah, actually what happens is that what you're trying to get at is you have a center core, and then you have an exoskeleton outside. So when you have an exoskeleton, what you do is that you support the entire slab from the core to the exoskeleton. So that's what we are doing one project like that. So there what happens, you have the columnless structure then. So you have an external column or you have an exoskeleton. So that becomes an aesthetic also part of an element. So you can do that type of buildings also. So these are the, but then finally I'll tell you all steel buildings, no matter how fast you go, 4-day cycle, 3-day cycle, core is the critical cycle. So you are stuck with the core. So who's addressing the core part? Either you go for steel enclosed sections, which become very expensive commercially. So I feel the answer is get rentable jump steel formwork. So can you rent that? You can't buy it, because if you buy it, you need a 45-story building to have a cost effectiveness. So you need to rent it.
To just add that point, we had similar problem statement, and he is very much part of our team in terms of understanding that problem statement. So we have done various exercises, right from RCC conventional, then with partially Maiwan and RCC. Then we have gone with steel, which is again IFC, which is core wall. Later we realized all these things, one way we are trying to stop in terms of or achieve efficiency on one side, but the other side we are losing. Like in IFC, we are able to achieve in terms of the time of erection, but the fabrication, it will take longer time, because that will come in panels of 1.2 meters and all. So then eventually now what we are doing, and we have been constantly doing, is slip form. Now we have moved to ACS, which is auto climb system. Slip form, we were able to achieve about 12 meters per week, which is about 2.5 floors per week. And our typical slab cycles comes out around 4 to 5 days as an average. So that meets to the requirement. So that way, having core, which is a rigid core, having lateral loads converting onto that, and then that RC core being considered with slip form is actually helping us to have the complete core taken up independently, while the steel keeps following up on the back. So this is what presently what we are doing it.
But who buys the core? Who buys the slip form? Is the contractor or the client?
Contractor.
Contractor. So you have to give
L&T
enough
does
work.
that.
And you have enough work in that
Okay,
area.
let me answer the question, because we are partners in that.
Why? Because we have got, see, you got volume of work in one place. What happens to an independent building? If I have to do one independent, there has to be a solution for that. If you want steel to propagate totally, you need to have a solution.
Correct.
You can't have a solution. Okay, in your case, you're doing 20 buildings.
Correct.
So you can afford to give the, promise the contractor that I'll give you 3 buildings. So his cost comes out. What happens if I'm doing a standalone building in Powai?
It's an absolute
Then how
right
do I-
question.
I think your point
I'll
is
leave
whether
to-
this is available on the rent basis, a slip
Yes.
form or a jump form. Right now, that facility is not there. Probably it's a good idea for us to implement as well.
So my sense is probably it is available. We are doing a project.
It is
where
available.
It's available, yes, that's true.
Self-climbing auto.
But that cycle time is a
which
little
is-
difficult, I think. I also know. While rentable. While we doing L&T business stuff, we did our own building, you know. Similar thing we had. We also had a spans of 12.5 to 14 meter spans. We also had RCC core. Initially, we dwelled upon to provide a steel core, but then, you know, it will take it will be very costly. At the same time, it will take time to do the bolting and all. It will be taking time. So finally, we decided to go for RC core, and then peripheral steel columns, CFT columns. So it took very less time, and Sunil was also part of the reviewing of our designs as well. So it was one of the first projects probably in India. I think Kalyan is taking in a big way now, but it's a good revolution which is happening in India. It's good for us. But your question of taking on rent is an idea which we also try
rent,
to do.
actually, it is available. Not many players. Yes, there are few players available, because in the process of identifying various options, we did reach up to few people, and that rental options is available. One good thing what I can say, in today's market, every aspect and every area, you have an asset-light model available. Irrespective of anything what you want, you have an asset-light model available. So even this rental is available. Yeah. So I'm saying adaptability,
Actually,
as much as adaptability we get. I'll
Yeah.
tell you a simple example. Tower cranes, what we use is luffing cranes. The first time when we started using luffing cranes, why do we use luffing cranes? The productivity per crane in terms of the element lifting and shifting and placing comes out to be at least 3 times faster when compared to that of a top kit crane. but luffing crane is 4 times costlier than a typical crane. So when time is money, everything comes in that way. Like we were discussing, when a contractor comes in, there's an approach saying that, okay, if I get 16 months of a duration or 12 months of a duration, he still gets the same cost. It is not that if it is 16 months, he's going to get more cost. If it is 10 months, he's going to get less cost because the projects are on an item rate primarily. So it is always better that he tries and utilize the equipment and infra as much as efficiently possible. So his element usage, if we calculate, then it comes out to be an optimal, and it becomes his responsibility and accountability to ensure that the infra which has been provided is rightly utilized. We have started with luffing cranes at least 4.5 years back. Today, we are holding about at least 8 to 9 luffing cranes in Hyderabad, and there is no other luffing crane in Hyderabad with anyone else. All the luffing cranes we have. But recently, with the same L&T project we have been discussing, same L&T has come back with comparison, at least 7-8 vendors with having those cranes available for offering. So now the utility has come. You can see across the projects, people are using it widely. By virtue of its sites are so constrained that you cannot have tower crane moving outside. You have to play within the site. So luffing cranes have become predominantly mandated.
Sunil,
yeah, go ahead.
regarding, we just talked about buildings, but now when you talk about stadiums, you talk about hangars, you talk about domes, so that's where the large, very large spans come in. So there you have to go for, tetrahedron elements with space frame, double heights, triple heights, so all that. So that's the versatility the steel gives you with different jointing systems, different welding systems or ball systems. So that type of flexibility you get in steel, which you'll not get in any, and if you're going for slabs and post-tension slabs and then the dead weights go up, the column sizes go up, and the spans become more and more and more. So steel is the best way to handle it. In fact, in factories also nowadays, we have started going for the decking, that your composite systems, which were never thought of. Now we are starting one now in Silvassa. Large spans with decking systems, composite decks.
So, you might not have realized that during this panel discussion, we have already covered around 7 to 8 attributes. Now, before we go towards the last question to the panel, I want Atul Bhai to take us through the future of construction or future of steel construction, how technology in terms of artificial intelligence or machine learning is going to help us. Atul Bhai, please, you can go ahead.
Thank you. Just make a point about what Kalyan mentioned, that one can use the GRC panels in the facade. One thing I should point out very clearly that RCC building is completely different in terms of detail when you do steel building. So if I have a wall, I can't go and hug the wall to a beam above. And there are multiple other small details which one needs to look at. So they are two different animals. One need to detail them out differently. It cannot be just swapped against the drawings done and change the columns or other structural element. Coming back to what Sunil was mentioning, we do believe that not in distant future, in foreseeable future, artificial intelligence would take over a lot of things what we are doing. And I believe that what happened when the CAD came or the first computer came or the BIM came, it is going to assist us substantially more. It is not going to replace anything for sure. What is important is how does AI help us in design, in execution, in planning is something which we need to start looking at. What we are doing in our office is to, in a small way, we have started things which is to look at AI differently, what it can assist us in design, what it can assist us in planning. I would strongly recommend professionals to look at it very, very, very closely because we do believe that it's next 5 years, things are going to be completely different. So it is going to be disruptive for some time. It is necessary for all of us to look at it closely because if we don't do it now, in future it will. One can start using drones instead of tower cranes, so I don't think they need to use laughing cranes. So I think things are going to be substantially different. You don't need to start looking at doing construction at one place. You have multiple drones which would lift and do construction at different places. And your pace of work is going to be substantially faster. So probably core in concrete may be different. It may not necessarily be the way we are looking at today, because still we will be able to construct much more faster than what we are doing today. So today what I understand is maximum 30 pieces you can lift with per crane. I mean, what I understand is we are looking at 100. Now, so this is really, really different. I mean, completely different thought process, and those needs to be plugged in not so very distant future, is what my belief is.
Thank you so much for sharing your thoughts. So before we go towards the concluding section, I would like to take few questions from the audience if there are any. So by now you know who all are sitting over here. And if you have any questions, please go ahead, and then we will take the concluding question to the panel. Please go ahead. Can somebody give him a mic, please?
Good evening. I'm Jaideep from EPAC Group. I just would like to ask one question. There's a huge opportunity of steel building coming up, the residential buildings coming up in steel. What I've seen majorly, whatever steel buildings are coming up, majorly they are from office buildings or commercial buildings. So is residential building competitive in terms of if you do in steel?
So we are presently doing 180-meter tall building, and we have completed 2 more smaller buildings. It is, of course, completely different in terms of details. There is no question about it. If I'm doing a commercial building vis-a-vis a residential building, I mean, as an end user, I would not like to see steel beams or deck sheet if possible, and the way toilets are built in India. So these are few challenges which we need to look at. We do believe that there is substantial necessity to do steel building. The way our plots are in Mumbai and the FSI is, we don't have option but to do steel. So we have finished one building completely, and the second is underway. And we do believe that there are a lot of learnings which we had, but it's comparatively much faster to do a steel building than concrete, for sure, particularly taller buildings. I hope that answers your question.
Sure.
One more point. In case, I think when you're doing steel buildings or residential, you have to, take care of 2-3 things. You have to, because what happens, your decking sheets can span only certain amount of, so you'll have to have secondary beams. So the clear headroom goes down. So that's a disadvantage. You can take a false ceiling and do that. And you need to basically allow some projections, because your column widths are going to be slightly, if you're going to encase your columns. If you are going to board your columns also, they'll come in. So the other 2-3 things, if you do your planning properly, I'm sure there is a way out. You can, again, your core is going to be in concrete. So that's a challenge which you need to do some sort of, some way you got to take care. Otherwise, you're not going to get the speed which you need, because that will be on your critical activity.
So actually, I should mention that we are doing a very high-end part of the structure in steel, which is stainless steel columns, which are concrete filled, and so very large. So we are doing deep deck. So I believe that these are addressable issues. Of course, one needs to day one plan for it, day one look at it very closely. But it is possible to do a very high-end product and also conventional multi-storied building.
I think Mr. Piyush Kapadia is sitting here. His own residential building has been somewhere, I think, 2012. He has made it in steel. And we supplied to him some 27 tons of steel for a project in Aurangabad, wherein he has designed a residential building of 3 stories. And it has come up in 45 days. So in residential, things are happening. And I think it is a matter of time before it picks up.
Thank you, sir.
There is no
That
doubt
answer-
it will pick up, and very shortly it will pick up. Any other questions? We'll take one more, and then we'll move towards the concluding part of this panel discussion. Is there any question? No? So now we will move towards the last part of this panel discussion. So everyone, starting with Mr. Panda, whether you call it as your wish list, whether you call it as the attributes, you call it as variables, you need to tell us that these are the, according to you, these are the 5 important aspects. If we take care before the start of the project, there is a maximum chance that the project will be successful. Go ahead.
So 5 attributes for me as a steel supplier, I would say, is that first you design in high-strength steel. For me, the greater you go for high-strength steel, the better off you are. And today, now that we have this fire-resistant steel, so my first attribute will be fire-resistant steel in E350, is what would give you the best. The second would be that you give us at least 7 to 8 weeks of advance intimation. Our supply time will be 4 weeks, but if you let us know in 8 weeks in advance, then I am able to do that. So that duration is there. The third attribute would be that we please customize your design. Don't go in for a 12-meter length or a 10-meter length only. We are most happy to give you a customized length. So, and save on steel, use lesser steel, and design efficiently. So I think these are the 3 attributes that immediately come to my mind. And,
First is basically, I think, the planning part from design angle. We need to do the design in conjunction with the architect, the client, and also the manufacturers. So we need to have the manufacturers come in, discuss what, and then prepare the design. Second is we need to design keeping in mind the contractor and design for constructability. It just don't design to satisfy the design and this thing. So that is very important. Because if you do that, then you can move fast. Third is, I feel, if you have basements, then you should start doing the steel right from the foundation. So that becomes, you kick off. So, you know, people feel, oh, you do the basement, then do the manufacturing, and then by the time you reach the ground slab, you have your set of. So why do that? You have to think little differently. So if sometimes we are doing 3 basements, sometimes we are doing 2 basements, or even 1 basement, why not just start from the foundation straight away? So you do the foundation and kick off. So there is where you can pick up, because speed, success depends on that. And of course, the other point is your elevation, the facade. So you have to detail the facade. So all this detailing has to be done from day 1. And once you do that, I'm sure that you will have a successful project, keeping that your core, which is critical, how you're going to handle that from to cost-effective way, is also the trump of the entire project. Because finally, I'll tell you something, the lift is the worst thing, because that is what your occupation certificate of when you have a building, the lift only delays you the most. So that is something which is the core. And for a structural engineer, the core is the maximum. It takes the lateral force it takes. So it's a very, very strong element for us. So that has to be really looked into properly. And the shape, we have to discuss with the architect and work around so that we can get a good shape for constructing it from, if you talk about slip form. Thank you.
So before going into attributes, I like to point 2 things which Hiten mentioned. Never have a crane in the elevator shaft. And that would make your life much more easier.
That's the wrong thing to keep in the lift.
Absolutely. And unfortunately, what we have noticed is most contractors want to do that. So, well, for me, one of the good things is to have steel with fire rating. So we can use steel independently on the facade without any specific treatment, and that would make architect's job a little more easier. So I do believe this is a tremendously good move to help the facade look much more easier, better. Of course, and what we do believe that in terms of detail, it is much more easier to do things if I can show those elements externally. The other issue in terms of design, I do feel that to make structural consultant very happy and have sleeker sections rather than very big. So that's what I would. Absolutely. So that's. That is it. Absolutely.
Yeah, he asked 5 attributes. First, to start the design. Design should be having a discussion with our manufacturers and ensure that the sections are available first. That is the first part of it. Second thing is design should be constructible. As Hiten was saying, constructibility of a design is very, very essential. And if you are able to perceive the construction methodology, that will give an edge. Otherwise, the contractor will come back to you and say, change the section. One is availability, second is erectability. So if you are able to think about erection part of it, then it will be much better design than what you do normally otherwise. So that is second point is erection. First point is design planning of the member sizes. Third thing is about the quality. Structural steel quality, there are minimal numbers, but they are very specific. If you're able to ensure the quality on site, it will be long lasting and also ensures the performance for us. So third part I prefer is the quality. Fourth is safety. Any construction has to be safe. We always vouch or target for a zero loss of life, and also near miss should be lesser. So these parameters of safety is a fourth point which we will prefer very much. And the last point is the cost. Whatever we do, if you're able to reduce the timeline, the cost will be the optimal. Like Kalyan was saying, unless you reduce the timeline, you cannot win our what we call as overheads. Our site will be there, they'll spend probably every month 4 crores, 5 crores with establishments. If you increase the number of months of stay, you will spend more money, which is, nobody will win. Contractor will lose, client also will lose. So it's obvious that you should reduce the timeline and also does reduce the cost. These are the 5 parameters I prefer as the options.
From my side, I just wanted to give an example. Empire State Building, 1930, 60,000 metric ton, done in 16 months of a time in 1930, with about 3,000 laborers working day and night, with 12-hour shifts, 2 shifts, people have been working, and they delivered the project in 16 months. In fact, it is 12 to 14 months what they say, and in few of the articles they say 16 months. But I'm saying we are talking still today, RCC structures, that's actually 100-storied tower, out of which 84-storied is an office floor, and balance is all with a spiral which is on the top. So everything is in steel, and there's about 20,000 metric tons of cladding material, this, that, whatever it is, and all said and done. 1930, we are at a stage today, we are almost 100 years ahead, and we are still discussing on time. So primarily what I just wanted to give this example at this stage is to understand that planning is very essential. So that doesn't come with one, it comes collectively and collaboratively. So everything in the supply chain has to get aligned. So it's something what we use together as a planning. I think I just took it from Hitenji, what he said is planning, and also further added my yourself added onto it. So I just wanted to take that point, saying that planning is a most critical thing. And if we do right planning at the right time, we can have the result which is good.
Thank you. I think we had a very detailed and engrossing discussion. I'm seeing the success factors little differently in the sense everybody's talking about the growth story of India. Means we are talking about a scale. Means speed to achieve the scale is going to be one key success factor for everybody in the ecosystem. This is number one. As for aesthetics, quality, various parameters will vary project to project. But I take two very important factors as success for entire ecosystem. One is creativity. So you need to be very creative, architect, the structural engineers, us. We need to be creative how to give you this small volume, how to give you various sizes. So creativity is one very important thing coming up together. Second is collaboration. Today, within 1 hour, we could unearth many things which we thought was not available or not possible. Within 1 hour, it was available and possible. Means we need to collaborate. One, to know it is possible, and second, to make it possible. So I take creativity and collaboration as two key success factors as far as this infrastructure story or construction story has to grow in next 20 years. Thank you.
Thank you so much. So guys, concluding remarks are something like that. Towards the start of this panel discussion, we did say that we are going to come up with a framework with number of attributes. So each and every expert, they have told about what they think or what are the most important attributes. And to be very honest with you, all those attributes which they have just mentioned are extremely important. And if we address those attributes before the start of the project will be definitely successful. But to close this particular panel discussion, I would like to tell you one thing, that there are most of the stakeholders of the construction industry are sitting over here. There are few are not there. For example, the developers are not here right now, or the project proponents are not there when we talk about the infrastructure projects. But all said and done, according to us, according to this panel, first of all these stakeholders, once they decide to collaborate, so that is the mantra of the success for structural steel projects. Thank you so much. Thank you.